So from our last class, we have impedance. I've taken that relation. So this is gone, this is gone. Because both of them are the two types I have discussed under reactance. I call one of them inductive reactance. I call one of them capacitive reactance. So capacitive reactance has this formula 2 pi Fa. So the capacitive reactance has this formula 1 over 2 pi Fc. While inductive reactance has this formula 2 pi. This is 2 pi Fa. Where C is capacitance and L is what? Inductance. Now, I've taken impedance as well. I gave you that impedance is the overall regulation. So the overall I mean here is that it is important for a resistor to be there. So it could be resistor and capacitor. It could be resistor and inductor, and it could be resistor, capacitor, and what? Inductor. If it is only resistor and capacitor, I can find impedance using this formula. If it is only resistor and inductor, I can use this formula to find impedance. But if it is resistor, capacitor, and inductor, I will always use this. Meaning answer here minus answer here, you square it, then plus the square of this, that's the value for impedance. Now, I said lead and lag. Those are the two terms I have on the board remaining. They are very important in AC. Because at times we say which one lead? Is it the current that lead or the... So lead and lag are very important. And they are showing the relationship between current and voltage. That is what they want to show. They are showing the phase. What happens when both current and voltage are moving? Meaning current, let's say from here now, both of them are coming. Both current and voltage, they are moving along the conductor. Which of them lead? The meaning of lead is very common. Lead means which of them gets to the maximum point first. So which of them come later? So the one that lead is called what? Lead. The one that come later is called what? Lag. So if both current and voltage are moving, and by the time current has gotten here, voltage just arrived here, it means current what? Lead. And it's leading by what angle? If you look at this angle very well, it is what? 90. So this happens almost in a pure conductor. Sorry, in a pure capacitor rather. In a pure capacitor, it is current that always lead, and it's lead by what? 90 degrees. Let me take it again. What do I mean by lead? From the word lead, here means that thing gets to the maximum point first, then lag. That thing gets to the maximum point later. Now, so if two things are moving now, the person that gets to the point first, we call that person, we say the person what? Lead. And the person that gets to that point later, we say that person what? Lag. So lead and lag are both showing relationship of what type of movement do we have for current and the voltage. So looking at the example I've just cited on the board, this is the starting point for both of them. Then both of them are moving like this, and they are going like this. So, and I said by the time current is already here, voltage just gets here. So if you look at the angle between this time, many current will move like this, like this. Now voltage has arrived here when current is already here. So if you look at the angle between this line and this line, you can see that the angle is what? Perpendicular, and it is nothing by what? 90. So which means they can lead by angle 90. So which one is leading? Anyone that lead by angle 90. Anyone that lag is also lagging by what? Angle 90. But they will not call it angle 90. They will say they lead by pi over 2. That is what they will say. When you come across many textbooks, they will say they are leading by pi. So they are leading by pi over 2. So, or they are lagging by what? Pi over 2. And pi over 2 is the same thing as what? 90 degrees. Because the value for pi in degree is 180. So what is 180 now? 180 degrees over what? 2. And that is what? 90. Now, let's explain. In a pure capacitor, it is current that lead and voltage lag. Take it again. That's it. I am giving you the summary now. So when the circuit is regulated by capacitor, current will always lead, voltage will always what? Lag. That's the summary. Now, for inductor, voltage always lead, current always what? Lag. In capacitor, current always lead. So when they say in the pure capacitor, what does current does? What does? So current lead and voltage lag by what? Pi over 2 degree, and that is 180 over 2, and that is what? 90 degree. But in an inductor like this, it is voltage that lead, meaning voltage get to the maximum point first, and current comes the end. Now, if one lead, then the other one what? Lag. In a capacitor, since it is current that lead, voltage what? Lag. In an inductor, since it is voltage that lead, then current what? Lag. So they are either leading by 90 degree or they are lagging by 90 degree. I'm very sure that one is very clear. Because this aspect almost gives students some serious problem. They don't know how to explain. So leading and lagging show relationship between currents and what? Voltage. In the phase of getting to their maximum point first. So the one that get to the maximum point first lead, while the one that get to the maximum point later lag. So summary is that in the capacitor, in the pure capacitor, current always lead, voltage always what? Lag. Then in an inductor, voltage always lead and current always what? Lag. So if you want to write what I've just said in word now, you will say IC, meaning current in capacitor, lead, then VC, voltage in capacitor, does what? Lag. That's how we write it. So this one is in what? Capacitor. So that's the summary in capacitor. Current in the capacitor lead, while voltage in the capacitor does what? Lag. That's the summary. Now in inductor, voltage in inductor, L is the symbol for inductor. Voltage in inductor does what? Lead. While current in the inductor what? Lag. So this is for what? Inductor. This is for inductor. So we continue from the next class.